Guys, so this is 2.3 functions. So in this section, we're going to talk about functions in general. Okay, so a function is a relation in which each element in the domain maps to exactly one element in the range. Usually the domain is our x, and usually our range is our y. Okay, so just some quick examples. If I have states here, this is my domain, you can think of this as your inputs, like your x's. Okay, I have Michigan, California, and Arkansas. Over here for my range, I have capitals, okay? So that's going to be my range or my outputs, usually your y's, okay? And we're used to getting an x, and then we can get an associated y. And notice that each one maps to exactly one capital, okay? If I had Michigan having two capitals, this wouldn't be a function. But since everything just maps out once, this is what we would call a function in this case. Let's look at this one now. In this example, we have people over here, three of my friends, Nate, Joe, and TJ, okay? That's my domain, my input, right? So give me a person and I'm gonna give you an output, the range, okay? And this is their gaming system. So Nate has a PS4, TJ has a Wii U, okay? And Joe, he really likes his games, so he has a PS4 and an Xbox One. Because Joe maps to two systems, this is not a function, okay? So for it to be a function, everything in your domain, your inputs have to give you exactly one output. Joe gives me two outputs. So if you say Joe, well, I don't know if the answer is PS4 or Xbox One, okay? So that's the idea behind not a function. Let's look at an example, a little more numerical. C. Here I have a set of ordered pairs. So points on the rectangular coordinate system, I have -2, 3, 1, -4, 3, 7, and -2, 5. This is not a function. My domain are all the x values, -2, 1, and 3. But notice that -2 gives you two different y values. It gives 3 and it gives 5. For that reason, not a function. Whereas if we look at D, 3, -4, 7, and 5, all of these, if you ask me what 3 is, I'll give you -2. If you say, well, what's y when x is 5? I'll give you -2. Everything goes to, and every x has a unique y value it goes to, and that's a function. Okay, so a little fact, in a function, no two ordered pairs can have the same first component and different second component. Just like there, how that's a problem. Okay, now, we also want to talk about domain and range. So I mentioned it a little bit earlier, but the domain, to be exact, is the set of all values for the independent variable. That's usually the x, just like we were talking about up here, okay? So for example, for C, our domain would be -2, 1, and 3. For D, our domain would be 3, -4, 7, and 5. The range is just the set of all values of the dependent variable, right? Y usually depends on x. So in C, our range is 3, -4, 7, and 5. Okay, so I want to show you some examples. So let's look at this one. We'll call this A. I have y equals x plus 1, and I drew the graph for you. Now, when I look at this, to tell if it's a function, if I pick any x value, it has to give me a unique y, which if I pick this x value, I get a unique y. If I pick this one, I get a unique y. If I pick this one, I get a unique y. Since I only get one y value for any given x value, I say that this is a function, okay? And its domain, we're going to list this out in interval notation. So its domain is the set of all x values. So if I scan this from left to right, I'm hitting every x value. That's what the arrow tells me. It tells me it goes on forever. So the domain here is -infinity to infinity. How about the range? Well, in the range, we're talking about all the possible y values, the outputs. Same idea, this is going to keep going down forever. I'm going, and that's going to go that way forever. The range is also -infinity to infinity. Alternatively, you could write all real numbers. Either way is fine. Okay, so let's look at a few more. Let's look at this one, B, y equals x squared. So if I look at any given x, I think I'm getting a unique y. One easy way to tell is a test called the vertical line test. You should be able to read this in your book. But essentially, if I pass a pen over this, notice that it only intersects the graph ever at most one point. If that's true, you've passed the vertical line test and you have a function. That's a quick way to check if every x has a unique y. Okay. And how about the domain? I'm just going to use D for domain. Well, that's all the possible x's. And it looks like this is going to go on forever in this right direction. It looks like it's going up, but it's still going to the right always. Same thing over here. So my domain, once again, is negative infinity to infinity. However, the range is a little bit different, okay? Where does this start? This starts at the point 0, 0. I don't have any negative y values. So I'm going to include 0 in the range and just go to infinity. Okay. So now we're right here. Let's look at C. X equals y squared. Now, if I use the vertical line test on this, notice that I'm intersecting in two spots. So I pick this x, it gives me two different y's. Because of that, this is not a function. But we can still find a domain and range here, okay? Your domain, we're looking for all the possible x values, starts at x equal to 0, because this is the point 0, 0. I'll include 0, and I'll go to infinity, because it keeps going in this direction. Its range, okay, it's going to keep going down forever, going to keep going up forever. So I scan it bottom to top, looking at all the y values. That's all the y values. So that's what we have right there. Okay, so there's a little introduction to functions.